Hi dear students, welcome to my channel. This video is useful for 8th standard onwards. In this video what we discuss is what is center of mass. You know what is mass? Any substance which has atoms that together. Okay. Any substance you call, you take a mobile phone, it has some mass. Then what is meant by center of mass? So if you take a mobile phone, it has some different shape, no? But where the center of the mass exists, what is the specialty of it? So center of mass, why we have to calculate? That we will discuss in this video. But when you are applying a force on any object, if that object is moving along the direction of the force, so at which point you applied the force, that point is definitely passing through the center of mass. Okay, now we will do one simple experiments to demonstrate where maybe the center of mass exists for a particular object. Okay, I will take one object and we'll do one experiment, right? See here, we are going to find out where the center of mass of this object. Here one pen is there. I am assuming the center of mass may be here. Is it correct? We will check. Means I am applying force here. So this object move together. Entire object should move along this direction. I will apply force here. I am assuming center of mass is here. It is not moving, it is rotating. Means center of mass is not here. Then where? You change the position. Instead of here, okay, we will see here. Somewhere here center of mass may be there. We'll check. I am applying force here. Somewhere here it is. You see, it is rotating. It is rotating. Means it must be between this point and this point. Now I am coming to somewhere middle point. Yeah, right. Means somewhere here center of mass is exist. That's it. If you apply a force on an object, if that object moves along the direction of the object, here some frictional force also comes. But in general, suppose it is in the air, you are applying the force at this point in the middle, it will move exactly like this. So if you apply the force beside this point, here or here, it will rotate. So only one thing you should understand here, if you apply a force on an object at the center of mass position, that object will move along the direction of the force, linear motion. It will go like this, straight. It will go like this it will go. So that point we are calling as center of mass, where total mass of the system is concentrated. So this is just like a king. This is a kingdom. This point is a king. So if you touch the king, entire kingdom is yours. So this point is most important. The center of mass is the most important for any object. When you apply the force at that point, entire object will move along the direction of the force. Okay. Now how to calculate center of mass for different systems? Suppose two particles are there. For two particles, why we need, that we will explain in this video. You keep watch forward, you will understand very clearly about center of mass. This is class number 90. Center of mass. Center of mass, simple definition I will tell you. Center of mass is a position where total mass of the system is said to be concentrated. Here first doubt, what is the system? See here. This is one example. This is x-axis, y-axis. This is a coordinate system. We need a reference system. Then only we can estimate or calculate where the center of mass is there. First I will tell you what is the system. Here two particles are there. One is M1, another is M2. These two particles I am calling, this M1 is at a distance of x1 from the origin. M2 is at a distance of x2 from the origin. We are going to calculate where the center of mass exists for this system. Very simple. XCM. This is x coordinate of center of mass. In fact, these two particles are lying along the x-axis. So it will have only x coordinate. Okay, XCM is equal to M1 x1 plus M2 x2 by M1 plus M2. This is simple. formula to find out the center of mass of the system. Here, one important point, you remember, center of mass lies between the particles. So definitely, the center of mass must be between M1 and M2, somewhere here. Okay. See here, example 1. This is x-axis and y-axis. Two particles. M1 is at origin. M2 is at a distance of 11 cm from the origin. So M1 is 1 kg. X1 equal to 0. X coordinate is 0. M2 is 10 kg. X2 equal to 11 cm. Okay. Now we are going to find out center of mass of this system. Since both are lying along the x-axis, the x coordinate of the center of mass xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. Simply substitute. M1 is 1, x1 is 0, so this is 0, plus M2 is 11, M2 is 10, x2 is 11, so 10 into 11 divided by M1 plus M2. 1 plus 10, that is 11, so 10 into 11 by 11 equal to 10 centimeter. So x coordinate of the center of mass is 10 centimeter, means somewhere here. It is very near to M2. Why? The reason is like this. The mass of second particle is much higher compared to first particle. So center of mass always near to heavier mass. This is proven. So center of mass is always near to heavier mass. This is important point you have to remember. You got it? See here, second example. This is coordinate system, x-axis and y-axis. Here two particles are lying in the plane. That is xy plane. So M1 is like this here. It has x coordinate x1, y coordinate y1. M2 is here, x coordinate x2 and y coordinate is y2. Means M1 is at a distance x1 from the origin like this, x coordinate. So from the y-axis, M1 is x1 distance. From x-axis, M1 is y1 distance. Okay, this is y1, this is x1. Similarly, M2 is at a distance of y2 from the x-axis. So M2 is at a distance of x2 from the y-axis. Simple, I am writing the coordinates of M1 and M2. M1 is at x1, y1. M2 at x2, y2. So we are going to calculate what is the x coordinate of the center of mass, y coordinate of the center of mass. Very simple. xcm, center of mass, x coordinate equal to m1 x1 plus m2 x2 by m1 plus m2. Simple formula. Similarly, y coordinate ycm equal to m1 y1 plus m2 y2 by m1 plus m2. If you go for 3 dimensions, suppose that particles exist in x, y, z, means in 3 dimension if you go, so they may have z coordinate of the center of mass. So x coordinate, y coordinate and z coordinate also there. That may be m1 z1 plus m2 z2 by m1 plus m2. So till now you remember these two. Center of mass x coordinate, center of mass y coordinate. These are the simple formulas we are going to use to solve the problems. Okay. This is example 3. This is also very easy. First I am choosing a coordinate system, x-axis, y-axis. Here I am taking 3 particles, M1, M2 and M3. So they are distributed like this. Here system is 3 particles, M1, M2, M3. 3 particles is my system. Okay. M1 is at origin. M2 is at a distance of 2 cm from the origin. M3 is like this. X coordinate 1 cm, Y coordinate is 1 cm. So M1 is 1 kg, M2 is 2 kg, and M3 is 4 kg given. So M1 is located at the origin. So M1 0 comma 0. X1 Y1 is 0 comma 0. M2 is 2 comma 0. Y coordinate is 0 here. So X2 Y2. Okay, 2 comma 0. M3 is here. X coordinate is 1, Y coordinate is 1. M3 is 1 comma 1. Now we are going to find out X coordinate of the center of mass and Y coordinate of the center of mass. Very simple. Here 3 particles are there. So M1 X1 plus M2 X2 plus M3 X3 by M1 plus M2 plus M3. So M1 is 1 into X1 is 0 plus similarly M2 is 2 into X2 is how much? X2 is 2 here, no? Plus M3. M3 is 4 into X1 is 1 like this. So M1 plus M2 plus M3. 1 plus 2 plus 4. 8 by 7 equal to 1.14 centimeter. Somewhere here, this is X coordinate. Somewhere here, X coordinate. Similarly, Y coordinate. M1 Y1 plus M2 Y2 plus M3 Y3 divided by M1 plus M2 plus M3. M1 is 1, Y1 is 0. This is at origin. So M2 is 2, Y2. Y2 also 0 here. So 2 into 0 plus M3 Y3. M3 is 4 kg. Y3 is Y coordinate, that is 1 centimeter. So 4 into 1. So this is 0, this is 0, this is 4 into 1, 4. 4 divided by 7 equal to 0.57 centimeter. Somewhere here. So X coordinate is this, Y coordinate is this. Means this is the center of mass of M1, M2, M3. What is the conclusion here? The beauty is the center of mass lies within this triangle here. That is concluded. So if 3 particles are there, join them like this. 3 particles, if you join them, it looks like a triangle. Center of mass of these 3 particles must be within this triangle. So I have concluded like this. Center of mass lies inside of the polygon formed by the particles. Here polygon is just like a triangle. If 4 particles are there, you join them. So within that polygon, the center of mass has to be present. This is an important thing. You got it?